Okay, so this is Tech Math 2, and we're going to do section 12-1, 12-2 today. And it has to do with graphing sines and cosines, trigonometric functions. So the first issue is, how are we going to, if we have something, if we have a sine function, y is equal to sine x, what does it look like? Well, it's going to start at 0, it's going to go up, it's going to go down, it's going to repeat itself, it's going to go all the way to infinity to the negative direction, all the way to infinity in the positive direction. It goes no taller than 1, no less than minus 1. So that's what it's going to do. And every period it's going to repeat itself. And that period happens to be 2 pi. So if I see something that's just sine x, that's what I'm going to do. If I see something that's sine a, y is equal to a sine x, what am I going to do? Well, now instead of just going to 1 and minus 1, it can go all the way up to a and all the way down to minus a. It still starts at 0. It still goes up, it still goes down, and it repeats itself forever and ever. And it's going to have a period of 2 pi. Alright, so now I've got something, and I got y is equal to 2 a sine bx. Alright, now it's still a sine function. It's still going to start at 0. It's still going to go up and down. It's only going to go up and down all the way to a and all the way to minus a, whatever the amplitude is. But now the period is going to be 2 pi over b. So now our period's at 2 pi over b, whatever b happens to be. So if b is a 2, then it's going to happen every pi. If b is a 1/2, then it's going to happen every 4 pi. Alright, so now the issue is, if y is equal to a sine beta x plus c, what's going to happen? Well, I'm still a sine function. I can only go up to a, I can only go down to minus a. I still have a period. My period is still 2 pi over b, whatever that is. But now I have a phase shift associated with this. So where is the 0? When is bx plus c, when is that equal to 0? Well, bx is equal to minus c, x is equal to minus c over b. So my 0 starts at minus c over b. That's my phase shift. I'm still going to go up. I'm still going to go down. I'm still going to repeat, but I'm going to repeat with a period of 2 pi over b. So this place is going to be 2 pi over b minus the phase shift c over b. Alright, now I'm going to do the same thing all over again, and I'm going to do that for the cosine function. So I got y is equal to cosine x. Okay, I can only go up to 1. I can only go down to minus 1. And I start at 1. I go down, I go up, I go down, I go up. I go plus and minus infinity both directions. And I repeat myself at my period, which is going to be 2 pi. So every 2 pi, I again end up repeating myself. So there I am at 4 pi now. Even though I don't look like I'm at 4 pi because my thing is pretty bad. So y is equal to a cosine x. All right, now I can go all the way up to a, all the way down to minus a. I still start at 1 times a, which is a. I'm going to go down, I'm going to come up, I'm going to go down, I'm going to come up, I'm going to go in both directions, and the same thing, plus or minus infinity. And at whatever the period, in this case it's 2 pi, I'm going to start repeating myself. Alright, now I've got y is equal to a cosine bx. All right, well, my function starts at a, can never get any smaller than minus a, goes down, goes up, goes down, goes up, repeats itself to plus or minus infinity, and the period is now 2 pi over b, whatever b is, 2 pi over b. I start repeating myself. And then I throw in a phase shift. Y is equal to a cosine bx plus c. And I say, okay, well, I only make it up to a, I only make it down to a. My period is still going to be 2 pi over b. And now it's a matter of where is my 0? bx plus c equal to 0. X is equal to minus c over b. So at minus c over b, I end up being at the top. I end up going down, coming up, going down, coming up, going the other way. And my period is going to be 2 pi over b, but that point has to be 2 pi over b minus cb. All right. Now, if the function is more difficult than that, then we'd want to make a table and do it that way. But that covers everything. Okay, so, yeah. That fast enough for you? Now, let's see what the front cover of your book says. And, yeah, doesn't help at all. So that means those are things that you'd have to remember. All right, so we're going to look at number 3. And number 3 wants us to graph y is equal to minus 3 sine x. Okay, well, that's fine. And find the amplitude, find the period, and graph at least 2 cycles. Okay, so my amplitude is 3. I don't write down minus 3 because what I left out in my discussion was the amplitude is going to be equal to the absolute value of whatever that number is. So we don't say the amplitude's minus 3, we still call the amplitude 3. The period is 2 pi. All right, so there we go. So now we're going to go all the way up to 3. We're going to go all the way down to minus 3. We're going to start at 0. But because we're negative, instead of going up and going down, we're going to go down, and then we're going to go up. So there we go. And we're going to go the other way too. And I have many more than 2 cycles gone. So that point would be at 2 pi. That point would be at 4 pi. And if I go the other way, this guy over here is going to be at minus 2 pi. And I have 3 cycles going. Now, it would have been better if this guy didn't come back that way. So maybe I should go and redo that part of the graph so it looks better. No, doesn't matter to you. There, is that now I didn't make it all the way down to minus 3. Bummer. Okay, well anyway. And none of my graphing tools are going to help me do that. So we'll now move on to number 24. Oh, I don't believe it. Look at that. Number 24. So I got y is equal to minus 240 cosine 120x. Okay, so they want to know the amplitude, 240, and they want to know the period, 2 pi over 120, which is pi over 60. Isn't that lovely? And we want to sketch this to 2 cycles. Okay, so because I'm negative, I'm going to start off at negative 240 instead of at the positive 240 guy. So I'm going to start there, and I'm going to go up, and I'm going to go down, and I'm going to go up, Boy, that's pretty bad, isn't it? Okay, well, it looks good. Then we'll go the other way. Up, down. Okay, so now the issue is, where does it start over? Well, that's going to be at minus pi over 60 and plus pi over 60, because that's my period. Okay, and because we've already done a theoretical discussion of phase shift, which is section 12-2, we go right to the problems in 12-2. So we're looking at number 3 in 12-2, and we see that y is equal to 2 cosine x minus pi over 6. And we find the amplitude, the period, the phase shift, and we want to sketch it. Alright, so the amplitude is 2. The period is 2 pi, and the phase shift is minus pi over 6 over b, which is 1. So the phase shift would be pi over 6. And when I put a pi over 6 in here, I see that I get pi over 6 minus pi over 6 is 0. So that's kind of an interesting thing too. And now I'm going to sketch it. And so I'm going to go up to 2, I'm going to go down to 2, but I'm going to start at pi over 6. It's a cosine function, so it'd be high there. I'm going to come down, I'm going to go up, I'm going to come back, and when I get back, I'm going to be at 2 pi more than pi over 6. So that would be 13 pi over 6. If I go back the other way, I go down, I go up, and I get to that point. That point would happen at 12 pi over 6 minus pi over 6. So that's going to happen at 11 pi over 6. And now I have 2 cycles. No, it just says sketch the graph. It doesn't even say to do 2 cycles. So I got the phase shift, I got the period, I got the sketch of the graph.
Would that be a negative 11 pi or not?
Yes, that's a negative 11 pi. Yes.
I just want to make sure.
Yeah. And, oh, it's right there. I can see it. About negative 11 pi. I don't understand what the problem was. All right. So next we're going to do 11. Number 11. Okay, so I've got y is equal to 2 sine 4 over 3x plus pi over 3. All right, well, my amplitude is 2. My period is 2 pi divided by 4 over 3. What's that going to be? 3 over 2 pi, right? And my phase shift is going to be minus pi over 3 divided by 4 over 3, which looks like minus pi over 4. And when I put the minus pi over 4 back into my equation, I see that I get a 0 in there. So that's my idiot check to tell me that I did something right. All right, so the function is going to go as high as 2, is going to go all the way down to minus 2. It's going to start at minus pi over 4. So there's minus pi over 4. It's a sine function, so it's going to go up to 2, back down to 2, and back to there. And then, so that's one cycle. And so 3 halves pi minus pi over 4 is what? That's 5 pi over 4, is it not? Because this would be 6 pi over 4 minus pi over 4, so I'd go to 5 pi over 4. And I would be done with that particular graph. Okay. Now the interesting part is that this is so simple that Wyatt is not even showing me that he is disturbed at all by this particular math. So I find that very interesting. Normally he's concerned about things like this. The class is laughing because Wyatt's not here. Oh well, can't have everything. Now Justin's going to go and look at all the tapes to see what we say about him when he's not here. Y is equal to 30.
I do have to do my homework.
Cosine, oh, that's the only reason you look? 160 pi x plus 8 pi. Well, isn't that special? Anyway, we want to know the amplitude, 30. We want to know the period, 2 pi divided by 160 pi. 1 over 80 is the period. The phase shift, minus 8 pi divided by 160 pi. 1 over 20. The phase shift is minus 1 over 20. The period's 1 over 80, so the period's less than the phase shift. Eight pi divided by that. Well, no, it is what it is. Okay, well, that being the case, we're going to go up to 30. We're going to go down to minus 30. And we're going to phase shift it back. There's 1 over 80. There's 1 over 40. There's 1 over 3 over 80 minus 1 over 20. Okay, and it's a cosine function, so it's going to start high. It's going to go down. It's going to go up and get back to there. It's going to go down. It's going to go up and get back to there. It's going to go down. It's going to go up and get back to there. It's going to go down. It's going to come up and get back to there. So that's a interesting problem, that the phase shift is more than the period. Oh well, can't have everything. And notice there's no pi anywhere because the pi got canceled out because we had it on the top and the bottom. So all I have is numbers. I wonder if I can do that in multisim. Now, the graphing calculators, even the dumb TI-83s and 84s that are in the room, will graph that for you. But it's not going to graph it for you in pies. So the one like this where the pi's gone and it's only a numerical thing, what you see on your graph is what you get. If I went in and put one of these other guys on there, so I went and put this guy in there, I would see this, but it wouldn't. That number wouldn't have a pi in it. It would be 4, something like. So 5 divided by 4 times pi. So I'd see on my calculator, I'd see this as 3.927. and not 5 pi over 4. But there's no technical reason why you just couldn't put it in your calculator and have your calculator tell you what it is, unless you're using a TI-36 Pro, in which case it's not a graphing calculator.
So what the answer is, we need like a 3.927.
Yeah, I wouldn't complain about that. I'd scratch my head. I'd have to figure out what you did, but I wouldn't complain about it. I might mark it wrong too, and then you could complain later, and I could change the grade. All right. Well, Monday we do other trigonometric functions. So we do the tangent and the cotangent and the secant and the cosecant, and those guys are much better. And then we do 12.4, which is more than one function, which is always a fun thing to do too. Okay, any questions? Don't forget to turn in your quizzes.
You do the bend